Okay, hello everyone. So we are back to our episode number 3 of the number series, and we are going to solve the problem from chapter 3, linear Diplock equation. And let's start with the first question. We are asking to give all the integer solution given by those equations. So usually how you do this is that you're gonna inspect a solution. In this case, I inspect the x equals to 2 and the y equals to 0. And you're gonna add a t to adjusting the corresponding to the slope of the equation. So we're gonna notice that if x increased by 1, then y should be decreased by 1. Like, okay, it doesn't matter that this one is minus, this one is plus. If you want, you can make it this positive, this one negative. It's just personal preference. And let's take a look at this. And yeah, if you see an equation that's maybe a little complicated, what you're gonna do is you're gonna also apply the Euclid algorithm and then do a reverse expression like I did here. You got 16 divided by 15, the remainder equals to 1. And that remainder of 1, you multiply by 17, that's going to be 17. And 1 can be replaced by 16 minus 15, just like what we did last chapter. And you get one of the solution and adjusting the slope or adjusting corresponding to the slope of this equation. So if x is increased by 16, then this must be decreased by 15. So 1 plus 1 minus. And yeah, that's how we get the general form of the solution. And there are more to it, and I'm not going to be very repetitive and repeat myself too much, and just check your work. And this one, you're gonna realize that they are sharing a factor of 3, which means that this should also be a factor of 3. But as we know, 17 is not a multiple of 3, so there's no possible solution to it. So, and let's take a look at question number 3. We're gonna find all the solution in positive integer for those equations. So after we find all of the general solution for each one of them, we should receive an inequality regarding to the value of t, and we're gonna combine that, and we can get all of the positive integer. Like this one, 3x minus 4y equals to 5. We're gonna realize that this requires x to be greater than or equals to 0, and this one greater than also or equals to 0. So combine those, we get t is greater than or equals to 0. And this one we simplified. We divided the number 3 for every single term on the left and on the right, and we get those two integer solution. And there are more to it, and just check your work, alright? I'm not going to repeat myself. And let's see question number 5. Okay, this is the first time that we got a system equation and involving 3 different variables. And the first thing you want to do is you want to knock out one of the variable and have a linear Diplock equation like I did here. I minus the second equation by the first one, and then I get rid of the x, and I have this thing left, and I got this expression here. And Yeah, you solve it and you got a general expression, and then you sub in those two expressions back to the number 1, and then you should be getting an expression of x by using the letter t, and you combine, you got all three nice number represented by t. And 6 is just similar, but you are actually applying this to a real world scenario. You got different value of coins, and there are 100 coins in total, and they have a total value of 4.99. And it's just similar process, so just check your work, alright? It's very straightforward. Question 7. A man bought a dozen of fruit, apples, and orange for 99 cents. If he bought, if the apple cost $3 more than a orange, and he bought more apples than the orange, how much of each did he bought? So we're gonna realize that he said a dozen. That means he have a total of 12 fruit, and he buy more apples than orange, which means x greater than y, and z gonna be the cost of the orange, and we got this equation. This one is a very interesting one because we got an inequality, which is most of the question don't really have. And number 1, we simplified by combining 1 and 2, and we got an equation about x and y and z, and we solve it. We got this general integer solution, and from 2 and 3 over here we can see there's a bound for the variable x, and x could be those values, of which there's only one legit solution satisfy this range. So we sub in x equal 9 back to those ugly equations, and we got the other two variables, and that's how we solve it. And question number 8. So the enrollment for a number series class consists of sophomores, juniors, and backward seniors. If each sophomore contribute 1.25, and each junior contribute 0.90, and each senior contribute 0.50, and the instructor at the end will receive a total of $25 of fund. And there are a total of 26 students, and this is the equation. And just follow the step that we have been discussed before, and you should not having a trouble to get this to be the answer. Okay, question number 9. So if the three merchants, they found a wallet and along the way, and one of them said that if I got the money and I shall become twice as rich as both of you. And the second one said if I get it, I gonna be thrice, which means 3 times as rich as both of you. And the last one says if I got it, I gonna become 5 times as rich as both of you. So we're gonna find the expression of how much did each merchant have and how much was in the wallet. So we got this to be our equation. P is the wallet, and the X, Y, Z, one, the first, the second, the third merchant we have in the question. So when you take a look at this, you're gonna realize that it is not really realistic to find a specific integer set, because just imagine that x, y, z, they have some kind of ratio. If you multiply by any number, the results should not be changing, and those relationships should still be satisfied. Therefore, there's no any particular integer set. we can only get the ratio relationship between all those four things. So from 1 and 2, and we got this expression, and combine 2 and 3, we got this expression, and then we combine those two, we can get an expression for z in terms of x, and then we sub in this to this. Now we can express z to by using the letter x, and we can express y by using x, and we got x, y, z to be represented by x. Now we can represent p by x. So suppose the first merchant is $X and y is going to be 3x and z is going to be 5x, and the wallet is 15x. And there's no way we can get a specific solution, so that's the final result. And question number 10, a man crushed the check for $D and C cents at the bank, assuming that he accidentally messed up the number of dollar and cents, and assuming that our main character, he did not realize that before he spent $23 already, and assuming further that he noticed that he have $2 and 2 cents, assuming still further asking that he wants to know what is the amount that the check was, assuming that I accept all the assumption, what is the final result? This one is a little weird. So this is the right equation, and you solve it, you got this to be the general integer solution. And this seems to be a very convincible solution, but there are really infinite solution. Suppose if he really get like more than 100 cents, but I mean, why would he get so many cents instead of dollar from the bank in the first place, right? So I think this is the smallest solution that I hope I'm not understanding the question wrong in any way. So this is what I got. If you got a different opinions, that means I'm probably wrong. So yeah, and that's all for today, and hopefully I can have the next video done very quickly soon. And thank you for watching.